Dear students, this is the seventh class of differential equations, and as we have started the solution of second order differential equations, and in this class we will solve homogeneous equation, that is second order homogeneous equation, and after that we will start the solving of non-homogeneous equation, and the solution of non-homogeneous equation will consist of different several classes, and this is the part one. So in this class we will learn how to solve a non-homogeneous second order differential equation, and a part of that. And let us start with the solving of homogeneous equation. So here is the second order linear homogeneous equation, and you know that the first order linear homogeneous equation has the form dy by dx plus py, that is equal to constant, that is equal to 0. But in case of second order differential equation, it has the form d2y by dx square plus a dy by dx plus by is equal to 0, where a and b are constants. And let y1 and y2, since we have seen that in case of a second order differential equation, solving this, since the differentiation of y with respect to ax is 2, that is the order is 2, so here will be two constants, and solution will be, and this is and this is and solution of this equation will provide you two linearly independent solution. Let's these are y1 and y2, and then the complete solution will be c1 into y1 plus c2 into y2, where c1 and c2 are the two arbitrary constants, and this is the general or the complete solution of the second order differential equation. Obviously this is a homogeneous case since the right hand side is 0, and this should and the solution should can be have obtained as y1 and y2, but these y1 and y2 should have follow or should have obey the condition, that is determinant y1 y2, y1 prime, that is the differentiation of y1, and y2 prime, that is not equal to 0. That means this determinant should not be 0, and this determinant is known as the Wronskian of y1 and y2. So to solve a homogeneous differential equation, you need to first test the value of the Wronskian. If it is 0, then it is not be solved. But if it is not equal to 0, then that is the Wronskian is not equal to 0, then the solution in the form y1 and y2 can be achieved. So now come here to the method to how to solve this type of equation, that is the linear homogeneous second order linear homogeneous equation. Just we have to substitute, just you take that y is equal to e to the power mx be the trial solution of the given equation, then find out the value of dy by dx, that is equal to m e to the power mx, that is equal to my, and d2y by dx square, that is equal to m square e to the power mx, that is equal to m square y. So now substitute the value of dy by dx and d2y by dx square in the given equation, that is this equation, and that will give you that from that you will have m square plus am plus b is into y is equal to 0, or from here am square plus am plus b is equal to 0 since y is not equal to 0, and this equation is called the auxiliary equation of the given different second order differential equation, homogeneous second order differential equation. That is the auxiliary equation of this equation of the given equation, that is this equation, is obtained here, that is m square plus am plus b is equal to 0. Since it is a quadratic equation, know that it will have two roots. Say these two roots are m1 and m2. So if m1 and m2 are two roots, then two solutions of the given equation will be y1 is equal to c1 e to the power m1x, and y2 is equal to c2 e to the power m2x, where m1 and m2 are the two values of m, and see here c1 and c2 are two constants. Then the complete solution will be y is equal to sum of this y1 and y2. So y1 plus y2, that is c1 e to the power m1x plus c2 e to the power m2x. However, there are three cases which are to be studied. These three cases are: number one, when the roots of the auxiliary equation are real but unequal. So you have already obtained that the auxiliary equation of the second order homogeneous differential equation is m squared plus am plus b, that is equal to 0. And from here you can write m is equal to minus, this is minus a plus minus root over a square minus 4b by 2 using Sridhar Acharya's rule. So from here m1, two values of m can be easily understood from this expression. So m1 is equal to minus a plus root over a square minus 4b by 2, and another one is m is equal to minus a minus of root over a square minus 4b by 2. If however b is equal to 0, then m1 is equal to, so m1, from this equation you can calculate m1 should be 0, m1 is equal to 0, and m2 is equal to minus a. Just write b is equal to 0 in these two expressions. So from here you obtain m1 is equal to 0 and m2 is equal to minus a. Then the solution will be y is equal to c1 plus c2 e to the power minus ax. This ax will be here, c2 e to the power minus ax. If however a is equal to 0 but b not is equal to 0, then from these equations m1 and m2, you can easily write that m1 and m2 is equal to root over minus b. If a is equal to 0, then y is equal to c1 e to the minus b x plus c2 e to the minus b x. Okay, so that can also be written as c1 plus c2 e to the power minus root over minus bx. Okay, no problem. Now come to the next one. Auxiliary equation has real and equal roots. So if you actually here find out the value of m1 is equal to minus a plus root over a square minus 4b, and m2 is equal to minus a minus root over a square minus 4b. And now if a square minus 4b is equal to 0, that means a square is equal to 4b. Okay, just see here, a square minus 4b is equal to 0 or a square is equal to 4b. From here you can easily understand that m1 is equal to minus a by 2, and similarly m2 is equal to minus a by 2. So that is here m1 is equal to m2 is equal to minus a by 2, and in that case the solution would be y is equal to c1 e to the power minus m1x, m1 is equal to minus half ax, plus c2 e to the power minus m2x, that means sorry, e to the power c1 e to the power m1x. So m1, the value of m1 is half a, then x, and c2 is minus half ax, and that can be written as c1 plus c2 e to the minus half ax, or y is equal to c is equal to c1 plus c2 e to the power ax. And alternative, this solution of these in this condition has an alternative form, that is y is equal to, if both m1 and m2 are equal, then you can alternatively write as y is equal to c plus then dx e to the power minus half x. C and d are both are constants. And another condition is here, auxiliary equation having roots forming complex conjugate pairs. That means in this case, if a is less than 4b, the roots of m1 and m2 forming complex conjugate pairs. Pair. So in that case, m1 is equal to minus a plus root over a square minus 4b by 2. Since in this case, a is less than 4b, so in that case, you can easily understand, you can find that m1 is equal to minus of a plus ik by 2, where k square is equal to 4b minus a square, and I is equal to root over minus 1. And m2 similarly minus of a minus ik by 2. And then the solution will be y is equal to c1. You know that e to the power m1x, so m1, the value of m1 is written here x, then c2 e to the power m2x, m2 is here x. So this can be written as c1 e to the power minus a2 by x, then e to the power minus I k x by 2 plus c e to the power minus a2 by a2 a by 2 into x, then e to the power I by 2 kx, and that can be written as e to the minus ax by 2, then c1 e to the minus ikx by 2 plus c2 e to the power ikx by 2. Now just write this term, e to the power this term or exponential term, as sine and cos term. So first I have written this term. So c2 cos kx by 2, then I c2 sin kx by 2. Okay, and then this term will be written as c1 cos kx by 2, then minus ic1 sin kx by 2. Just simplify. This term is here c1 here from c1 and from c2, then cos kx by 2 plus I, and then this c2 is here and this c1 is here, sin kx by 2. That is equal to, this term is also written here, e to the minus ax by 2. It will be e to the power ax by 2. Then a cos kx by 2 plus b sin kx by 2, where a is equal to c1 plus c2 and b is equal to c2 minus c1. So here it should be e to the minus ax by 2. So a is equal to this and b is equal to this. So this is the solution. So the solution will be y is equal to minus ax by 2, a cos kx by 2 plus b sin kx by 2. So this is the process, how the method how to solve uh, a homogeneous linear equation, second order homogeneous linear equation. As there are, here are some examples. I am offering some examples here. First one is d2y by dx square minus 5dy by dx plus 6y is equal to 0. Now the process is, the method is to first consider that y is equal to mx is the trial solution of this equation. So from here dy by dx is equal to m e to the power mx, that is equal to my, and d2y by dx square in the similar way m square y. Just substitute the value of d2y by dx square and dy by dx in this equation. The auxiliary equation would be m square minus 5m plus 6, that is equal to 0. And from here just factorize it. You will get m minus 2 into m minus 3. This is equal to 0. And from here you can write m1 is equal to 2 and m2 is equal to 3. So the solution will be y is equal to a e to the power m1. m1 is equal, in this case, is 2, plus b e to the power m2. Here is m2 is 3, so 3x. A e to the 2x plus b e to the 3x. So this is the solution. Now solve another problem, that is the 2y by dx square minus 4 dy by dx plus 4y is equal to 0. And similarly you have to use the process of method of trial solution, that is y is equal to the mx. So I am not writing here that parts. You can directly understand from this equation that the auxiliary equation should be m square minus 4 m plus 4 is equal to 0, and this can be written as m minus 2 whole square is equal to 0. That means m1 and m2 both are equal and having a value of 2. So in that case, the solution will be y is equal to e to the a e to the 2x plus b e to the 2x, where a and b are arbitrary constants. And the alternative form is y is equal to, we have already discussed that alternative form is y is equal to a, then plus bx e to the 2x. So this is the solution. Now another one is here, d2y by dx equals 2 dy by dx plus 5 is equal to 0. And you know that this cannot be factorized, but there are trial solutions. So right here, the trial solution is this, y is equal to mx, and after substituting the value of d2y by dx square dy by dx, we will have the auxiliary equation as m square plus 2m plus 5 is equal to 0. And this cannot be factorized. So you have to use the rule of Sridharacharya. That is, from that you can find out the value of m as minus these two plus minus root over this 2 square minus 4 into the coefficient of m square and this 5. So 4 into 1 into 5 by 2 into this, the coefficient of this m square, that is 2 into 1. This is 2 into 1. So that is equal to minus 2 plus minus root over minus 16 by 2, that is equal to minus 2 plus minus 4i. This will give you 4i by 2, that is equal to minus 1 plus minus 2i. So m1 is equal to minus 1 plus 2i and m2 is equal to minus 1 minus 2i. So this and the solution there will be y is equal to a e to the power minus 1, that is m1x, and b e to the power m2x. So from this, simplify this as e to the minus x, a to the 2ix plus b to the 2ix. And the alternative form is, the alternative form is if m1 is equal to alpha plus I beta and m2 is equal to alpha minus I beta, that is in this case alpha is equal to minus 1. So the solution will be y is equal to the alpha. So alpha is equal to minus 1 alpha x. E to the alpha x means e to the minus x. Then constant a1 cos beta x. Beta is in this case is 2. So 2x, then another constant v1 sine beta x. Beta in this case is 2. So y is equal to minus x, a1 cos 2x plus b1 sine 2x. This is an alternating solution of this given equation, where all these a's and b's are constants. Now solve another equation, that is d2y by dx square 6 dy by dx plus 25y is equal to 0. And similarly, in this case, the auxiliary equation is m square plus 6 and plus 25 is equal to 0. And from here, you can easily understand that this cannot be solved easily, and say the Archer's method should be applied in this case. And m in this way calculated the values of m as minus 3 plus minus 4i. So here two values are of m are m1 is equal to minus 3 plus 4i and 2 is equal to minus 3 minus 4i. So the solution is y is equal to e to the power minus 3x, then a1 e to the 4i plus b e to the minus 4i. An alternative solution is there also. Y is equal to these 3, so e to the minus 3x is there, and in this case this is so 4 and this is also 4, so it would be a cos 4x plus b sin 4x. This is the solution. Now come to the solution of the second order linear non-homogeneous equation with constant coefficients. You know that we have already understand that the homogeneous second order homogeneous equation can be represented by d2y by dx squared plus a dy by dx plus by that is equal to 0. If it is right hand side is 0, then it is homogeneous, but if it is not 0, rather it is a function of x, then it should be called a linear non-homogeneous equation. Obviously, it is the order is 2, so it is second order linear non-homogeneous equation. And it is important to solve this kind of equation. And to solve this equation, you need to first equate this the left hand side as 0. That means d2y by dx squared plus a dy by dx plus by is equal to 0. That means the homogeneous the left hand side should be first you need to equate this equation is equal to 0, and from there you can find out the value of y. And the value of y you have calculated in this way is called the complementary function. So the first process is to make the left hand side is equal to 0 and then calculate it and then solve for y and find out the value of y, and that y is said to be a complementary function of this differential equation. And after that, the second part is to find out on any particular solution of this equation given equation, and which can be obtained by following several processes methods that will be discussed uh, in next some slides. And this solution is called the particular integral. So two things we have to do. First one is to equate this left hand side is 0, and from there you have to find out the complementary function. And number two is find out the particular integral of this equation of the given equation using, obviously there are several methods we will discuss in later some slides. So from there the solution in that case obtained is called the particular integral. After that, so already you have obtained the complementary function and the particular integral, and then the general solution or complete solution would be the sum of the complementary function and particular integral. If complementary function is y1 and particular integral is y2, then y is equal to y1 plus y2. This is the complete solution of the given second order non-homogeneous differential equation. And in finding out the complementary function, that is in that case you have equated the left hand side to 0. That means that was the solution of a homogeneous equation, second order homogeneous equation. In that case you need to remember these conditions. So that is the roots of the auxiliary equation because in that case you have to find out the auxiliary equation, and then you have to find out its roots. And you know that depending upon the roots, the complementary function will have the different forms that are summarized in this table. So if a1 and m2 real and unequal, then the complementary function will be a e to the power m1x plus b e to the power m2x. And if m1 and m2 are real and equal, then the complementary function will be a plus bx to the power mx. If, however, the roots are a pair of imaginary, if the auxiliary equation consists of pair of imaginary roots in the form alpha plus I beta and mt is equal to alpha minus I beta, that is m is equal to alpha plus minus I beta. In that case, the complementary function will be e to the power this alpha. The real part will be here e to the power alpha x, and the imaginary part that is beta. So that will produce that will give you a cos beta x plus b sin beta x. So this is the complement. This is the form of the complementary function. Well, the values of m1 and m2 will have the form alpha plus minus I beta. Okay. Now another important thing is to understand or to know, that is d operator. So the d operator is defined represented by ddx. So in solving differential equation, d operator is a very important tool, and it is a very strong tool to solve differential equations, especially for non-homogeneous differential equation. And for non-homogeneous second order differential equation, to find out the particular integral, these d operators are much more important. And in the knowledge of these d operator will help to find out the particular integral of a second order non-homogeneous differential equation, and it is denoted by capital D. So the mathematical definition of the operator is d is equal to ddx. Okay, so the d operator has the same function as that of ddx, and in the similar way, d2 is equal to d2 by dx square and d3 is equal to d3 by dx cube. So dy by dx can be represented by capital D into y, and d2y by dx also can be represented by d2y by d2 into y. And in the similar fashion, d2ny by dxn can be represented by d to the power n y. So, so so the nth order differential equation having the form dn d2n by dxn plus a d to the n minus 1 into by dxn minus 1 y b d to the n minus 2y d xn minus 2. In this way, y can be written by using d operator as dny plus a dn minus 1y plus b dn minus 2y. In this way, ny is equal to 0. Or you can write if a function of d into y is equal to 0, a function of d is equal to dn this dn a into d to the n minus 1. In this way, d to the 0. In this term, d to the 0. So you can write in this fashion also. So differential equation, second order differential equation can be suited, can be written in this way, in this way, and you will find, you will understand, or you will know in the next some slides that the beauty of applying d operator in solving the differential second order differential equation, especially to find out the particular integral of the non-homogeneous second order differential equation. Now, properties of D operators. D operators have some different several algebraic properties which are very needful and very useful in solving differential equations. And here are some properties are summarized. These are d of e plus b, where u and b are two functions or two variables. You can write d u plus b is equal to du plus dv, and d plus m over y, where m is a constant, can be written as m plus d into y. Also in this sense, d square plus ld plus m into u can be written as d square plus m plus ld into u, or ld plus m plus d square into u. But generally this L square LD can be written in this can be in this way, and d to the power n into d to the power m into u can be written as d to the power m plus n u, and that can also be written as d to the power m d to the power n u. And d of ku can be written as k of k into du, where k is a constant. But remember this thing, that is d of uv cannot be equal to u of dv. That means d does not commute with u, does not commute. So the value of uv, d of uv is different form of u into dv. And here are some another two things to remember, that if u is equal to d into v, then v can be written as v is equal to d inverse u. And in this case, d inverse is d inverse stands for integration. That is, inverse means you know that the inverse of differentiation is integration. So d inverse will provide integration. So here are some properties like this. Here I is equal to 1 by d, that is d inverse, and d is equal to, similarly you can write d is equal to 1 by I, that is equal to I inverse. I means integration. So I square can be written as d to the minus 2, and in this way I to the power n can be written as d to the power minus n, etc. Now Here are some important relations involving the operator. So as already I have told already that I have said that the D operators much have important roles in solving second order non-homogeneous equations, especially for the particular integral. So we need to know the properties of D operators, and D operators the operators follow some uh, relations, important relations that will be very beneficial in solving second order non-homogeneous differential equations. Here are some properties, here are some relations, that is dn e to the power x. dn e to the power ax can be written as an e to the power ax. Okay, and you can use the value of d as d1 or d2 or d3, then you can easily prove it. And then function of f d to the power ax can be written as in this case this a is replaced should be this a should be replaced by a, that is fa e to the power x. So in this case a d is replaced by a, function of d is written as function of a e to the power x. In this way 1 by fd e to the power ax can be written as 1 by fa e to the power ax. Obviously, the condition in this case should be obeyed is fa not equal to 0. If fa is equal to 0, then this relation uh, should not be obeyed. So now come to some examples. The first one is d2y by dx square minus a to dy by dx plus 16y is equal to e to the minus 6y. So this is a non-homogeneous equation. So to solve this, you need to first equate the left-hand side is equal to 0, from where you can find out the complementary function. And after that, you have to find out the particular integral of this equation. So first, let us start. Let us find out the complementary function. So the given equation is here, and this can be rewrite in d operator, in form of d operator, in this fashion. So now the auxiliary equation, so you have to use the trial solution as y is equal to u over mx, and after substitution of different values of d square and d in this expression, you will have the auxiliary equation as m square minus 8m plus 16 is equal to 0. And from here you can easily understand that m1 is equal to m2 is equal to 4. So in that case, the complementary function y1 will be, if m1 and m2 is equal to 0, then it will the solution will have the form a plus bx e to the power 4x. A, B are constants. And this is the, now look here, this is the method how to find out the particular integral. So to find out the particular integral, say the particular integral is y2, that is equal to write 1 by fd. So in this case fd means function of d. So function of d means this term, d square minus 8d plus 16, that is here 1 by function of fd, then this term, the right hand side, e to the minus 6x. So if you wish to find out the particular integral of a second order non-homogeneous equation, so you have to write that particular integral is equal to, the expression is 1 by fd, then the right hand side into the right. So that is here. So this can be written as 1 by d minus 4 whole square e to the minus 6x. And you know that in such cases, so this has the form like this, 1 by fd to the x. And in that case you can equate, or you can find out from, or you can get from this equation that this can be written as 1 by fa, that means d is replaced by a e to the power x, subject to the condition fa not is equal to 0. So if you replace d by this 6, so that will in that case fn is not equal to 0, so it can be applied in this case. So that is done here. So y2 is equal to 1 by d is equal to, in this case say sorry, a is in this case is minus 6, so minus 6 then minus 4 whole square e to the minus 6x, that is equal to 1 by 100 e to the minus 6x. So the complete solution is the sum of the complementary function and the particular integral. That means a plus bx is equal to 4x, then plus 1 by 100 is equal to 6x. This is another problem is here. Solve d2y, d2 d2 plus 4 into y e to the 3x. So the auxiliary equation can be directly written here, m square plus 4 is equal to 0, and from here m is equal to plus minus 2y. And you know that this has the form m is equal to alpha plus minus beta I. where alpha is equal to 0 and beta is equal to 2. So the solution complementary function will be y1 is equal to a e to the power alpha x. Alpha is 0, so e to the power alpha x. Alpha is equal to 0 here, so e to the power 0, that means 1. So that is 1. And then a cos beta, beta is here 2, beta x plus b sine beta x, and this is the complementary function. And now the particular integral, you know that particular integral is calculated by the expression y t is equal to 1 by this function d square plus 4, then into the 3x. Now function of fd is to be replaced by function of a, that is here. So d square should be replaced by 3 square. In this case a is 1, so 3 square plus 4, that is 1 by 13 into the 3x. So the complete solution is y is equal to y1 plus y2, that is the complementary function plus particular integral, that is equal to a cos 2x plus b sin 2x plus 1 by 13 e to the power x. So this is another solution of another problem. Another one is here d2y by dx square plus 3 dy by dx plus 2y is equal to e to the power 2x. So from here you can write the auxiliary equation as m square plus 3m plus 2. Just factorize it. You have obtained that m1 is equal to minus 1 and m2 is equal to minus 2. So the complementary function will be a e to the power m1x, that means e to the minus x, then b e to the power m2x, that means e to the minus 2x. So now the particular integral is, now you have to calculate the particular integral. The particular integral, you know that it can be calculated by using this formula, that is y2 is equal to 1 by fd. Fd is here, fd is a d square plus 3d plus 2. So that is a d square plus 3d plus 2, and then the right hand side, that is e3 e to the 2x. So that is, and you know that this can be factorized as d2, d plus 2 and d plus 1. So that is e to the power 2x. Now d should be replaced by these two. E to the x, a is here 2, so this 2. So that is done here, 3. This 3 is here, 2 plus 2. Then d is in this case 2 plus 1 e to the power 2x. So 3 by this 4 and this will 3 is 12 e to the 2x, that is 1 by e to the 2x. So the complete solution is this y1 plus this y2, that is there. So this is a complete solution. Another problem is here, this is solved here, so just go through this. This is not very difficult, you can easily understand uh, the calculation of the complementary function and the particular integral also. So the complete solution in this case is 2 by 7 e to the 3x plus e to the minus 4x. Now solve another one, that is there, d cube plus 2d square minus 5d plus 6 into y is equal to 4 e to the power x. So the auxiliary equation in this case would be m cube minus 2m square minus 5m plus 6. Just factorize this. That is done in this process, in this way. Go through this. Finally you get m1 is equal to 1 and m2 is equal to 3 and m3 is equal to minus 2. That is, in this case you got 3 values of m. So no problem with 3 values of m, just go in this way. So complementary function y1 is equal to first a1 e to the power m1x, that is there, e to the power x, then b another constant e to the power this 3x, plus then another constant c e to the power this minus 2x. Okay, this is the complementary function. And now the particular integral, that is written, that is denoted by y2, that is equal to 1 by fd. So fd is here, function of fd, that is d cube minus 2d square minus 5d plus 6, that is here. Okay, that is here, and then e to the 4x, the right hand side. And now you can factorize this in this way. You can write a d minus 1, then d minus 3, then d plus 2 e to the 4x, and this is just written here. So in this case you just to simplify this, to simplify this, you need to replace this d by this 4. So that is here 4 minus 1, then 4 minus 3, then 4 plus 2 e to the 4x, and this will give you 1 by 18 e to the 4x. So the complete solution is the complementary function. The complementary function is this, and the particular integral is this. Now another problem is here. So this is the same, exactly same problem. See here, this d cube minus 2d square minus 5d plus 6y is equal to e to the 4x. This is the same problem, but in this case the right hand side is e to the power 3x. So the complementary function, finding the complementary function is as well, is as That was in case the previous solution. So that is a to the x plus b to 3x, c to the minus 2x. So in the case of particular integral, it is somewhat different from the previous one. So this is the function of fd. Just summarize is just the 1 by d minus 1, d minus 3, d plus 2, e to the 3x. So in the first two cases, this one and this one, in these two cases, d minus 1 and d plus 2, just replace d by 3, then fa is not equal to 0. But in this case, d minus 3, see here, in this case, if you replace d by 3, this 3, then this will give you fa is equal to 0. So in that case, this d cannot be replaced by 3. So I am writing here separately it 1 by d minus 3, because in that case, this is separated from the rest two parts. And the rest two parts 1 by d minus 1 and then d plus 2 e to the 3x. Now, since this t cannot be replaced by 3, so I am writing here separately. And in these two cases, d can be replaced by 3. So that is done here. And then y2 is 1 by d minus 3. And this will give you 1 by 10 e to the 3x. Now, to solve this is a problem. So to solve this, say 1 by d minus 3 e to the 3x is equal to z. Just write this 1 by d minus 3 e to the 3x is equal to z. So from here, d minus 3z is equal to 3x. From here, you can write dz by dx, because you know that d is equal to dz by dx. And then minus 3z is equal to 3x. So this is first order differential equation, and it is obviously first order linear equation. Obviously it is non-homogeneous. Okay. So linear equation. So to solve this, you need to find out the particular integral, and this has the form, which kind of form? dy by dx plus px, then that is equal to q. So in this case, p is equal to minus 3. So the particular integral will be p, sorry, in this case integrating factor. This is not particular integral, it should be integrating factor. So the integrating factor will be not it is particular integral, it will be integrating factor. Integrating factor is equal to e to the power minus 3 dx, that is to the minus 3x. Now you have to multiply this equation with this integrating factor. So it is if, it would be if. So integrating factor. So e to the minus 3x dz by dx minus 3z e to the minus 3x, that is equal to 1. So now the left hand side you can write ddx of e to the minus 3x into z, that is equal to 1. Or from here, d of e to the minus 3x into z, that is equal to dx. Okay. Just integrate both sides. So you will have e to the minus 3x into z is equal to x plus c is integrating constant, or z is equal to x e to the power 3x plus c e to the power 3x. Okay, so from this equation, so y2, so we can use this equation, equation number 2. Y2 is equal to 1 by d minus 3, 1 by 10 e to the 3x, so that will first give you 1 by 10 this x e to the 3x plus c by 10 e to the 3x. So the complete solution is the sum of this term and the complementary function that is here. That is, so the sum is there. Here, sum is here. Okay, another problem is here. d2y by dx square minus 5dy by dx plus 6y is equal to e to the 2x. So when x is equal to 0, y is equal to 1, dy by dx is equal to 1. That means at the value of x is equal to 0, y is equal to 1 and dy by dx is equal to 1. So in this case, see here, the boundary conditions is given. So if the boundary conditions are given, then we can find out the value of the coefficients. So rewriting this equation in d operator, you have d square minus 5d plus 6y equal to e to the 3 to e to the power x. So the absolute equation is m square minus 5m plus 6 equal to 0. It is the factorization process. M is equal to 2 and m2 is equal to 3. So complementary function y1 is equal to a to the 2x plus b to the 3x. And the particular integral would be 1 by this function of this function of fd, that means d square minus 5d plus 6, then the right hand side e 2 e to the x, that is this 2 is here 2, and you know that the factorization of this term will give you m, that means d minus 2 and d minus 3 e to the power x. And in this case you can comfortably replace d by f, function of d by function of a. That means d can be replaced easily, comfortably by a. A in this case is 1. So 2 by 1 minus 2 and 1 minus 3 e to the power x, that is equal to e to the power x. So the complementary complete solution is y is equal to 1 plus y2. y1 was a e to the power 2x plus b e to the power 3x plus ex. This is equation number 1. Now just differentiate this equation with respect to x. So dy by dx, that is equal to 2 into a to the power 2x plus 3 into b into the 3x plus a to the power x. Now just impose the boundary condition. The first boundary condition was y is equal to 1 for x is equal to 0. Just use this condition. So here dy by dx from this relation. So y is equal to 1, that is here, and x is equal to 0, that means a plus b plus 1. So from here a plus b is equal to 0 or a is equal to minus b. And the second boundary condition is y is equal to dy by dx is equal to 1 for x equal to 0. Just use that boundary condition and just use in this expression, and from there you can find out b is equal to 0. Here is that. And if p is equal to 0, then a is also 0. So both a and b are 0. Both a and b are 0, and in that sense the solution is y is equal to e to the power x, only e to the power x. So go to the next one. Here is the next one. Solve for the differential equation d2y by dx squared plus dy by dx minus 12y is equal to e to the power x. So in the d form you can write this d operator this, and here is the solution for m1 and m2. So m1 is minus 4 and m2 is equal to 3. So y is equal to a to the 3x plus b to the minus 4x. And now find out the particular integral y2, that is equal to 1 by, you can write this as this d function of d as 1 by then d square plus d then minus 12 e to the power x, and this can be factorized as d plus 4 then d minus 3 e to the power x, that is equal to 1 by 1 plus 4. Here d is replaced by, in this case a is 1. 1 plus 4 and 1 minus 3, that is 1 minus 10 e to the power x. So this is the solution. And the another one is here, this is y double prime minus d 2y prime plus y is equal to 4 e to the 3x. In this case double prime means differential double derivative, and y prime means single derivative, that is d double b double y prime, that means d2y by dx square. So d operator, in d operator you can write d square minus 2d plus 1 y is equal to 4 e to the 3x. And here you can find out the complementary function y1 is equal to this, and the particular integral is here calculated here, and after calculation, after calculation you have y2 is equal to e to the 3x. So the complete solution is this term plus this term, that is here. Just differentiate this, you obtain this. And here is the boundary condition, y is equal to 0 for x equal to 0. Just use the boundary condition here, y is equal to 0 for x equal to 0. That is done here, and from here you obtain a is equal to minus 1. And the boundary condition, second boundary condition can be applied, should be applied this expression, for this expression, that is y prime is equal to 0 for x equal to 0, and that will provide you b is equal to minus 2. So you have already obtained a is equal to minus 1 and b is equal to minus 2. Just substitute here that in this expression y is equal to minus 1, then minus 2x e to the power x plus 3 to the power x. This is the complete solution. So this is the first part of solving of second order non-homogeneous differential equation. In our next class we will learn how to solve the other differential second order non-homogeneous differential equation, and we will proceed the second part of solving of non-homogeneous differential second order non-homogeneous differential equation in our next class. So just you need to practice and everything will be clear to you.